In section 1.7, we reached the last section of the chapter. We're going to represent functions as graphs. And just like we did in the previous section, we can work with tables. These will be input-output tables, and we want to make sure to observe a certain convention here when we make our graphs. And that is that our input variable, or the independent variable, will go on the horizontal axis. So that's going across, normally called the x-axis. And then we're going to put the output variable, or the dependent variable, on the vertical axis, which is normally called the y-axis. So here's an example where we have a table of input and corresponding output values, and then from that we have ordered pairs, input, output. So an input of 1 gives us an output of 1. Input of 2 gives us an output of 3. And then we graph those ordered pairs. And remember to graph horizontal first, then vertical, x, then y. So from the origin to graph 1, 1, we would go to the right 1 and up 1. To graph 2, 3, we would start at the origin, go 2 to the right, and up 3. 3, 5 would go 3 to the right, up 5, and 4, 7, 4 to the right, up 7. Okay, so make sure that you're putting your inputs here on the horizontal axis, outputs on the vertical axis. So let's look at a couple of examples. So here we're asked to graph the function y equals 1/2 x with domain 0, 2, 4, 6, and 8. So first of all, we want to complete this table. We have our input values. We want to calculate the output values by multiplying by 1/2. So this tells us take 1/2 times our input. So 1/2 times 0 would give us 0 for our output here. Then 1/2 times 2 would give us an output of 1. 1/2 times 4 gives us an output of 2. 1/2 times 6 will give us an output of 3. And 1/2 times 8 will give us an output of 4. Now we have our ordered pairs, and in this case, because of the way the table is set up, our ordered pairs appear in columns, etc. So we have a point at 0, 0, right at the origin. Then 2, 1, so 2, 1, 4, 2, so go to 4 on the horizontal axis and up 2. 6, 3, so we go 6, and then 3, and finally 8, 4, so 8, 4. And notice that these form a straight line. Should we therefore connect the dots and make a line? In this case, no, and here's why. We do have a function given to us, and normally we would go ahead and graph that function as a straight line, but in this case we were specifically given a domain with 5 exact values, and so we should only be showing 5 points corresponding to those 5 values in the domain. So just graph the points and you're done. Okay, number 2 is going the other way around. Here we're starting with our graph and we need to determine a rule for our function, and then we'll determine domain and range. Okay, so for our rule, another little hint to look for your rule is look what happens when you go to the right one. And by the way, pay close attention to your interval here. Notice the intervals so far have always been going by 1. Each line represents 1 unit. Okay, it won't always be like that, so be careful. But in this case, when you go to the right one, go up 1. To the right one, up 1. To the right one, up 1. So there's a 1-to-1 correspondence, which tells us we're going to be multiplying x times 1. So we're going to have y equals, here's our output, our dependent variable, is equal to 1 times x, or in other words just x, and then we'll need to add or subtract something in most cases. In this case, when we have an input of 0, in other words x equals 0, our output is 1, we have to add 1 to get there. And we can double check that. When x is 1, we add 1 to get y equals 2. When x is 2, we add 1 to get y equals 3. Add 1 to 3 to get 4. Add 1 to 4 and we get 5. So it checks out. Our domain will be the x values of those 5 points on the graph. So the domain will be 0, 1, 2, 3, and 4. The range will be the y values of these points. So that would be 1, 2, 3, 4, and 5. And notice from that simple formula of y equals x plus 1, that means our domain is always going to be 1 less than our range, or in other words, we add 1 to the domain to get to our range. So you can see the relationship there. Okay, number 3. The graph shows membership in a local math club in the years 2008 to 2012. Identify the independent variable and the dependent variable. Describe how membership has increased over the time frame. What would you expect the membership to be in 2013, and do you think this pattern can continue indefinitely? So here we're looking at 1, 2, 3. We have an interval of 1, but bear in mind this is the year since 2008. So this would represent 2008, 2009, 2010, 2011, 2012, etc. And then on the vertical axis, notice we're going by tens. So we started with 10 members, and then we were up to 20, and then 30, and then 40, and then 50. Okay, so our independent variable is along the horizontal axis, so we can start with that. So independent variable is going to be time, or years since 2008. The dependent variable is along the y-axis, the vertical axis, and that's our membership. Okay, now what's happened? How has the membership increased over the time frame? Membership has increased, and you can see a steady rate there of increase. Membership has increased, and for each year that we go forward, we're going up 10. So membership has increased by 10, that's a 10, not a 16, 10 members per year. Per year since 2008. Okay, and what would you expect the membership to be in 2013? So this is going to be a prediction for 2013, because we have no way of knowing for sure. If we're sitting in 2012, we have no way of knowing for sure what it will be the following year, but we're going to predict, as long as it's following this trend, that it's going to go up by 10 again. So if it was sitting at 50 members in 2012, then we would expect 50 plus 10, or 60 members for 2013. And then finally, do you think this pattern can continue indefinitely? Well, if you stop and think about it, if this keeps going up 10 per year, eventually we're going to reach pretty much the whole student body, and then even more than that. So, and you would have to go out quite a ways here. But if you were to continue on that trend, eventually you're going to get to the point where you have more members in the math club than you have students, which probably is not going to happen. So basically this is an opinion question because it asks, do you think? But I would argue that this pattern cannot continue forever. Okay. If you have a reason why you think it can, such as the student body will continue to increase, we're going to get a bigger school, then you can go ahead and make that argument. Just make sure that you explain your reasoning. So this pattern cannot continue, or the math club would have more members. The math club would have more members than there are students. Okay. So there we go with a little bit of reasoning and get a little bit of writing in there too. We'd like to see some complete sentences there. All right, so there you go with the last section of chapter 1. Good luck and enjoy preparing for your test.